Welcome back, folks. In today's class, I'll be talking about the new chapter, that is chapter 6.2. And in this one, we will talk about the binomial theorem. So in the previous class, if I can recall, we learned about the probability, and we also talked about if there are multiple events, how we gonna find out the probability for the multiple events. For example, if there is a tossing of the coin, there is head and tail, and in the second event, after getting the one's head or a tail, what's going to happen, you can in the next toss of coin you can get a head or tail, and here also you can get the head or tail. And this is what we talked about, the series of events. And then if there is a third trial, you can again get a head or a tail. You can get a head or a tail. From here also you can get a head or tail. From here you can get the head or tail. So we learned about how we can find out the probability of finding the three heads, two heads, and all those things. Now, in today's class, what we're going to do is we're going to learn how we can solve these the same question using the binomial theorem. But there are certain conditions which we need to follow to apply the binomial formula on a given question. For example, uh, if let's say this is the question given to me where we toss the coin three times, whether I can apply the binomial theorem on this one or not. Let's see. So I need to first of all know the requirements for the binomial theorem. So these are the four requirements. The first one is all the outcomes of an experiment are classified into the events of success and failure. So there can only be two outcomes. It means it can be success or a failure. Well, success and failure are just the names. It can be yes or no also. It can be true or false also. So means there will always be two outputs, yes, no, success, failure, or true or false, head or tails. And then the second one is there is a fixed number of trials. Means there cannot be a 3.5 trials. There cannot be infinite number of trials. There should be an n number of trials, fixed number of trials. And then the third one is the trials must be independent and repeated under the identical condition. So if whatever condition you applied to the first trial, same conditions should be applied to the second trial, and the probability of getting the output should remains exactly the same, and which leads to the fourth point: the probability of the success and failure must remains the constant throughout the journey. So these are the four conditions which we must satisfy, and we can apply to the question of head and tails, where we said that we are tossing a coin three times. In the first time you get the head or tail, in the second time what are the different options you get, and the third time you got what are the different options you get. Let's see whether we can apply all these four conditions to this question of tossing up the coin three times. So all outcomes in an experiment are classified into success or failure. So whenever we talk about tossing up the coin, there is only head and tail. So there are only two outcomes. So the first one is satisfied. The second one is the fixed number of trials. Yes, in this case, we have three trials. So second one is also satisfied. The trial must be independent and repeated under the identical condition. So this means that if you toss up the coin once, whatever the condition were here, same condition should be while tossing up the coin second time and the third time. So whenever the n number of times you are taking the trial, so for all those n number of trials, the conditions must be same and they should be independent. Independent means the probability should not change for the output. So for example, if I toss a coin, what is the probability of getting the head? The probability of getting the head is 50%. And then what is the probability of getting the head when you toss up the coin second time? Again, 50%. And what is the probability of getting the head in the third toss of the coin? 50%. So in the individual trial, the probability is same. So these point number three and point number four are kind of interlinked. Independent means the probability does not change, and that leads to the fourth point: the probability of success and failure should remain same. So if it is 50%, it should remain 50% throughout all the three events. All right, so now based on these conditions, we can find out the answer of our given question using the binomial distribution also. So let's apply the binomial distribution. to the tossing of the coin 3 times. I will write down here what is the probability of getting 3 heads. So here I'll write the formula equal to binom.test. This is the formula we're going to use. Let me quickly see whether everything is getting recorded or not. Yes, everything is getting recorded. So binomial.test, there are 4 arguments in this one: the number, the trials, and the probability, and the cumulative. So I'm looking for 3 heads. So I'm going to place 3 here, comma, the trials. The number of trials is 3, comma, the probability. This probability is probability for the individual event. Mark my words, this is for individual event, not the probability of getting 3 heads. Probability of getting a head in an individual trial. So that is 0.5, comma, cumulative, or uh, true or false. Means true means cumulative, false means uh, exact value. So right now I'm going to put the false, and then I'll talk about in detail also what is the difference in false and true. So let's see what we get. Yes, we got the probability as 0.125, and I can match my answer that how many outputs can be here in the given question. The number of outputs are 8. So those outputs are, you can have head, head, head. You can have, this is the first one, head, head, tail, head, head, tail. Third is head, tail, head, head, tail, head. Then is head, tail, tail, head, tail, tail. Then is tail, head, head, tail, head, head. Then tail, tail, head. Well, tail, head, tail, tail. Then tail, tail, head, and then tail, tail, tail. 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, only 1 is 3 heads. So 1 over 8, which comes out to be 0.125. So our work is correct. So binomial experiment can be applied to this question. Now I'm going to try and create a table the way we created the table in the previous video. If someone haven't seen the 6.1, I've created a table. Go and watch that video and then come back to this one. All right, so let's create a table. Let me delete this one. So I'm gonna say x is the number of heads, and then px is the probability. So probability of getting, first of all, I'll start with 0 head, 1 head, 2 head, and 3 head. Probability of getting 0 head is equal to binom.test. Binom.test, this is the one I'm going to use, and the number is this, comma, number of trial is 3, comma, probability is 0.5, comma. As I said, I'm going to keep on using false. False means exact probability. So something which we learned in the last class also, equal to this. So this means if I have to write it in the mathematical form, this will be p x equal to 0. What is the probability of getting the 0 head? Now this one, probability of getting 1 head will be, I'm just gonna bring it down from here. Let's see what's gonna happen in this one. So in this one, probability of getting 1 head, I've selected this cell, and then number of trials is still fixed, 3, and the probability of individual trial is 0.5, and then the false. So this will be probability of getting x equal to, well, here probability of x equal to 1 in this one, and then probability of x equal to 2, and then, well, not negative here, and then here probability of x equal to 3. So that's what this probability table is. And then if I also sum these probabilities, you're going to get the 1 also. Now I'm going to try and see where, what does the true means. So here I'm going to try and see, I'm going to apply the true here. So down here, equal to binom dot dist, and then number is this one, comma, trial is 3, comma, probability is, comma, 0.5, 0.5 comma true. So this is the cumulative probability. Cumulative means the previous ones are also included. So how I'm going to write it? I'm going to write it probability of x should be less than equal to 1. So this means at most 1. What is the probability of getting at most one head? Means I have to include the 0 head and the 1 head. So both are included. 0 head comma 1 head. 0 head comma 1 head. They both are included in this process. So that is the probability of getting the 1 head. What is the probability of getting the 2 head? So if I add these two values here, so that will be the value. And let's see whether I can get it using the binomial or not. Equal to binom dot dist, and then number is 2 comma 3 comma probability is 0.5 comma true. Let's see what's the answer for this work. 8.875. Okay, so it means at most 2 head. So true means, the meaning of true will be at most. That's what true means. Now, all of a sudden, if I ask you to solve this question for at least 2 head, what is the meaning of that? I wanted to solve it for probability of x greater than equal to 2. This means at least 2 heads. One more time, if you are watching this video, chapter 6.2, straight up without watching the 6.1, then you may not be able to learn it thoroughly. So I will highly encourage you to watch the 6.1 because I've talked about all these things in detail there. Now, let's continue talking about at least. So now, because the sum of all these probabilities, this, and this, all this probability is 1. So if you add all these ones, so at least 2 head, how can I solve it using the binomial formula? So total probability is 1. So I'll press equal to 1 minus probability of, well, let me remove this, 1 minus probability of getting at most 2 head, x less than equal to 1, not 2, shall I say, because I'm including 2 here. So 1 minus probability of at most 1. So if I use my marker and try and show you, 1 second, I think I left my markers somewhere while solving this question. Anyhow, I'm gonna try and show it without using the marker. Let me quickly find it, otherwise it's not gonna be good. Oh, found it. Yeah. All right. So x value, as I said, this is, for this I will write it at least 2. So it means 2 and 3. At least 2 means 2 and 3, which is equal to, total probability for this one is 1 here. 1 minus probability of these two. That's going to also give me this. So that's another way of representing. Earlier, what we were doing was, when I said at least 2, when I wrote it like this, probability of x greater than equal to 2, I wrote it as probability of 2 plus probability of 3 in the last video. Now rather than writing it this way, what I'm trying to say is you can write this same thing in, like, okay, probability of x greater than equal to 2 means at least 2. I wrote it as probability of 2 plus probability of 3. I can also write it as x greater than equal to 2 as 1 minus probability of 1 plus probability of 0, which in turn can be written as probability of x greater than equal to 2 equal to 1 minus probability of x less than equal to 1, means 1 minus at most 1 probability of at most 1. That's how you can write it as. So hopefully you were able to understand. So this one thing can be solved by these three different ways. Majority of the time when we are using the binomial theorem, we're gonna keep on using this method, because the formula you use, equal to binom dot dist and number comma trial comma probability comma true, this is used for at most. So probability of x at most less than equal to whatever number here. So this means whenever you're going to use this formula, this is a formula for at most. Okay, and when we have to use find out for at least, we're gonna use it this way. Hopefully you were able to understand what I am trying to teach you here. Okay, and if you haven't been able to understand, go back and watch this recording again, and I'm sure you will be able to understand. All right, now let's look into one of the questions down here based on the concept we've just learned. A student writes a test consisting of 20 multiple choice questions. The student has done some preparation for the test, and based on the sample quiz has the probability of 0.7 has a probability of 0.7 of answering each question correctly. What is the probability of this student getting in the answer of at least 15 out of 20 questions correctly? Now, if I see this question, it is telling me that the probability of answering the question correctlically is given to me. So probability of success is consistent for every question. Probability of 0.70 of answering each question. So there are 20 trials. Every trial has a success rate of 0.7. That is given to us in this question. And you can get only two answers. Either means you can only get two outputs. Either you write the correct answer, or you uh, do not get the correct answer. Okay, so that is also satisfied. So pretty much we satisfy all the conditions which are here, which are required to satisfy the binomial experiment. So there are fixed number of trials, 20 success or failures. Either you get it right or you get it wrong. And are they independent? Yes, they are independent, because the success probability is consistent, that is 0.7. All right, let's try and do this question now. So at least 15 out of 20 questions correctly. So how I'm going to write it? So I'm going to put P, start the bracket, X should be greater than equal to 15. At least 15 correctly. At least 15 correctly. So I can write it as total probability, which is 1. Always sum of the probability will always be 1. 1 minus probability of at most 14. That's what's going to give you the final answer, getting at least 15 correctly. So that will be, I can write it as 1 equal to 1 minus probability of x less than equal to 14. So I'm looking for minimum. I shouldn't put the equal to. I'm looking for minimum 15 correctly. What is the probability of that? So means 15, 16, 17, 18, 19, 20, all of them will satisfy in this. So I'll write it as equal to 1 minus binom dot test. It should be 14, I wrote it at most 14, so my apologies. So this will be the answer. Thank you. And all the questions correctly. All the questions correctly means P equal to X 20. Now for that one, equal to binom dot test, and number is 20, comma, number of trial is 20, comma, probability is 0.5, comma, cumulative, that is, in this case, that will be, well, I'll use false here because this is equal to. Whenever there is an equal to, we will always go for false. So exactly 20 correct. So that's what I did. It should be 0.7, and that's the number we're gonna get. And now the next one, some questions incorrect. So some questions incorrect means the probability of not getting exactly 20 right, not getting x should not be equal to, not equal to, equal to 20. Okay, some questions, it says some questions incorrectly. So that will be 1 minus probability of getting all the 20 correctly, 1 minus this number. So equal to 1 minus this number, that's going to give you the answer. All right, so final one, no more than 17 questions correctly. So probability of at most x should be less than equal to 17, at most 17 correctly. So that will be equal to probability, well, binom dot dist, which is the number down here is 17 comma 20 comma probability is 0.7 comma I will use the true in this one. That's going to give you the final answer. So hopefully you were able to understand how to use the binomial distribution. Okay, I'll see you with another video. Till then, goodbye.